Welcome back to my channel. In this video, I'll be taking you through review exercise of point sets. So I have a couple of questions here which I'm going to take you through. The first question is saying that let I, that is I1, I sub 1, to be equal to a set where S is a member of all real numbers, where X is greater than -4 and X is less than or equal to 4. And we have I2, which is an interval, and this is a half open interval, so -2, 8. Then the sub questions are saying that find I1, which is the intersection, or just find I, which is the intersection of I1 and I2. Then the second is saying that find the midpoint C and the radius delta of I. The third one is saying that use the absolute value inequality to define I in terms of the radius delta and C. So now let's see how we're going to solve this problem. So I have I sub 1 to be equal to a set. So let me take the X, which is a member of all real numbers. So that one is understandable. Now this set is having an internal interval, which is -4, then less than or equal to 4. Then we have I2, which is giving us a half open, half closed, -2, 8. So the closed part is for the -2, meaning -2 is included, but 8 is not included. Now let's see. If we want I, which is the intersection of these two, we know from sets, that is from high school level, that if you want to find intersection of two separate sets, what do? You need to get the members. Once you get the members, you will know what or which element appears in each of the sets at the same time, right? So now looking at I1, which is a set of values of X which are greater than -4 but less than or equal to 4. So now let's try listing I1 here. So I1 is simply going to give us something like -4 is not part because X is greater than it. So maybe -3, -2, -1. You have 0, 1, 2, 3, and 4 inclusive, right? Then let's see I2. I2 will give me, so this an interval where it started from -2 to 8. Okay, so let's say -2, I'll have something like -1, I'll have 0, and it should end at 7, right? So looking at these two intervals, if I want to find the intersection, meaning that what are the common terms, I can see -2 here, I can see -2 here, meaning that my new interval I should have the very first or the smallest element to be -2, because it is -2 that is common to the two sets in comparison. Then we go to the last one. You realize that I2 has the biggest number, but here it ends at 4. So I can't say that it should end at 7 because you're looking out for elements which are in both sets. So I can see here I have 4, and surely I'll have 4 here. According right, so let's say 1, 2, 3, then 4, right? So I'll end at 4. So we can get an interval. So he said find the intersection I. Find the intersection I from the question, right? Of I1 and I2. So I'm going to get something like a closed -2 because -2 is part of it, then negative and +4, right? So +4 is also closed. So this is the interval and is the intersection of our I1 and I2, and that solves the very first problem. Now let's see the second one. The second problem is saying that we should find the midpoint of C and the radius lambda of I. So right now we need a midpoint. Now if you have an interval, right, and you want to find a midpoint, what do? You just take your endpoint, you sum them up, then you divide it by what? By 2, right? That gives us the midpoint of our interval. So here from -2 to 4, if you want to find the center of it, so let's try listing them manually. You're going to have something like -2, 1, 0, 1, 2, 3, 4. But take note, you realize that this is an interval. Apparently, if you are to list the numbers or all the elements of this interval, you cannot list them because somebody will start from -2 and moves on to 2 -2 and move on to, let's say, -1.999999. Yes, and that is also part of this. So we are just using these integers for simplification, right? So now let's see something here. We are looking out for midpoints. So what will be exactly the midpoint in this set? So if you are counting, you have 1, 2, 3, 4, 5, 6, 7, 8. So meaning the midpoint should fall at exactly the fourth position, right? So 1, 2, 3, 4. So that should be this. That should be our single one. But how do we get 1 as a midpoint? So as I said, if you have any sets A, comma B, the midpoint is simply given as A plus B divided by 2, which is apparently the average of what? Your interval. Okay, the average of your interval. So now let's see something here. This is going to give me um this will give me -2 plus 4 all over 2, which is the same as +2, because you have -2 adding to 4 over 2, and that will give us what? Simply 1. And indeed 1 is the center of our interval, because if you move here, -2, -1, 0, then you move to 1. From 1 you move to 2, 3, 4. So we can see that after, on the left side of 1 we have 3 elements, on the right side of 1 we have what? Other 3 elements. So having got the midpoint, let's move on to, okay, so it's continued to say that we should find the radius delta of I. So how do you find the radius of I? Radius of I. Now remember that to find the radius, we need our center. Okay, we need our center. So our interval is simply having -2 here and it's having 4 here, and we know that the center here is 1. That's the midpoint. So if we want to find the radius, meaning that we want to find any distance from the center to the any of the endpoints, right? So here I'm going to have, if I represent here with A, I represent here with my C, and here as my B, my center is simply equal to, sorry, my radius is simply equal to C minus A, or B minus C. This is because B is bigger than C. So if you want to find the distance here, which is delta, you simply have to subtract the smaller one C from the bigger one B. Here is also delta because radius is just a magnitude, right? Once you have center, from the center to any of your endpoints is radius, obviously. Then it's also equal to C minus what? E, right? C minus E. So simply, if you want to find our radius, you simply write radius. So our radius is simply going to give us C minus A. So my C is 1 because my midpoint I had 1. So 1 minus -2, giving me what? 1 plus 2, and that will give us 3. So meaning that our radius is 3. In other way, you can also say that 4 minus 1, and that is also 3. Okay, 4 minus 1, that is also 3. So this is how we solve simple intersection, midpoint, and also um, radius problem. Now let's see the second part. Okay, even we have our last section. Is that use the absolute value inequality to define I in terms of delta and C. Absolute inequality. So what absolute inequality is saying that, you know, generally we have x minus c is less than what? Our delta, right? X minus c is less than delta. And we know that this delta is the radius. We know that our c is what? The center, and this x. All that we are being required of from here is that we should represent our interval as this. That is all. You just have to make substitution with your center and substitution with what? Your delta. So I'll have absolute of x minus my c is 1 less than my delta, which is, so less than my delta, and my delta is simply what? 3. That's all. So this is what you need for the third part. So x minus 1, absolute of that should be less than 3, and that is the absolute value inequality to define I in terms of delta and c. So using this, that's all. So this is what you are doing. So this is the absolute inequality, right? Now let's see the second part. It says solve these tasks. solve. I have a couple of absolute value problems here for us to go through systematically. So now let's see. Let me clean this side. So we start solving them here, small. Okay, so let's go. I have the very first one to be absolute. A is giving us absolute of 4x minus 3 is less than 4. So how do we solve this? Now, to solve any absolute value problem, yes, you can use the neighborhood approach, or you can simply use the concept of absolute as anything that comes out of our absolute sign as what? Positive, right? So meaning that you can have let's say 4x minus 3, this thing here, we can have it to be less than 4, right? That is when I take positive of whatever I have inside. Or I can say that if it happens to be negative, it will be negative 4x minus 3. I mean negative of the whole expression. This is what I mean. Whenever you have absolute of, let's say, absolute of a, this is the same as a can be what? Either 1 or what? Negative 1. Yes. So a here can either be negative 1 or 1, and it will give you the same value. So if you are withdrawing a value from an absolute sign, don't just consider the positivity. Just see that if it had also been negative, the absolute will make it positive. So you seeing a positive inside absolute sign doesn't confirm that it's just a positive number. That is why we consider the two options. Here we are considering when it's positive. So when it's positive, it will be less than 4. When it's negative, you still bring less than 4. But remember that you divide through by negative. So you get 4x minus 3 to be greater than what? Negative 4. You get it? So you can see that this expression here, 4x minus 3 is greater than negative 4. Then I can just simply bring greater than here and I'll bring negative 4. As simple as that. So whenever they give you something like this, you simply have to take, this whole thing less than this, greater than, negative of 4. That's all. So once you have got this expression here, I've just combined this and that. So we can now take this one off here, right? So with this absolutes here, what I'm going to do is whatever you do for the left, you do same for right. If I want to solve this, I will first make sure that my x is standing there alone. To do that, I need to clear off this negative 3. So I have to what? Add it to both sides. Or I have to add 3 to all sides. So negative 4 plus 3 less than 4x minus 3 plus 3 less than 4 plus 3. So doing so here I'll get negative 1 less than, this will cancel this, right? 4x less than 7. With this expression, what do? I need to divide through by what? The coefficient of x, and that's going to give me negative 1 on 4 less than x less than 7 out of 4. And this gives me my solution for my absolute value equation here. And this is how we solve. So you can simply rewrite this in an interval form as open brackets, which is open. You have negative 1 out of 4, comma 7 out of 4, like this. Now let's go to the second part. Okay, so for the second part, let's see. So with the second part, that is B, I have absolute of negative 2x minus 10 is greater than 6. Now, whenever you see greater than, you have to take good care of that because it can be very confusing. It's not as less than. Whenever you get a greater than here, as we did here, we can decompose this absolute equation into two forms. I'll have negative 2x minus 10, which is the original thing I'm seeing here, should be greater than 6. Yep. The next thing is, I'll have negative of what is inside, negative 2x minus 10. That is, I'm assuming that what is inside is negative. So you have to attack the negative, but bring it out of the expression. Okay. So should be what? Also greater than what? 6. But here you simply divide through by the negative so that you get negative 2x minus 10 to be what? When you divide through by negative, it will 10. This sign will 10. and I'll have negative 6 here, right? So with this expression here, what do? I simply have to combine, because negative 2x minus 10 is less than negative 6. The same negative 2x minus 10 is greater than 6. Is there a way to combine it? So can I say that I'm making it negative 2x minus 10 is greater than negative, sorry, is greater than 6? Then here it's less than negative 6. Is that possible? And do you think that you can have something to be greater than 6 but less than negative 6? That doesn't make sense, meaning that we cannot combine it this way. So the only exception for greater than inequalities is you have to do them separately. Unlike this side that I combined, here I have to do them separately. So if I want to tackle, I'll tackle this first. Then once I do that, I come to this side. So tackling this, what do? I send the 10 out. So negative 2x will be greater than 16, right? X will be greater than, now I have to divide through by negative 2. So the sign will change and it should be less than. So you let me make it um negative x is greater than 8, right? Then after x will be less than negative 8. Then you put this one down. Then let's come here. When you come here, I have negative 2x minus 10. I will do same. Negative 10 will go. I'm going to have negative 2x less than negative 6 plus 10. Okay? Here I'll get negative 2x to be less than what? 4. And I'll have here to be x to be greater than, remember negative, if I'm dividing through by negative 2, x should be 10 as a greater than, then here I'll have negative 2. Okay, so here you are seeing that the solution for inequality is x less than negative 8 or x greater than negative 2. X less than negative 8 or x greater than negative 2. Now what is x less than negative 8? We simply have negative infinity comma negative 8, right? Negative infinity comma negative 8, and that is the symbol for what the interval form. So negative 8 is here, union. Now when I come to x is greater than negative 2, what do I get? I'm going to get something like negative 2 comma positive infinity, like this. So this is the interval for our solution. Either x is negative infinity to negative 8 union negative 2 to positive infinity. Now let's move to the C, the third part of our inequality. The third part of our inequality. So let me try squeezing here because I want to see the question here. So if I want to do the third part, C is giving us absolute of 3x plus 1 is less than 5. With this absolute, it's the same as the first one we did. So whenever you see it's less than here, the next thing to do is write your 3x plus 1 should be greater than negative 5 and less than 5. That is what you should always do. Whenever it's less than this, don't worry yourself. Bring negative of this at the right side and left side and bring greater than. That's all. At this point, 1 will move out, 1 will move out. Okay. Negative 5 minus 1 less than 3x less than 5 minus 1. I'm clearing off this one. Here gives me negative 6 less than 3x less than what? 4, right? At this point, what do? I divide through by the coefficient of x, and that will give me negative 6 on 3, which is negative 2, less than x, less than 4 on 3. And this gives me, open brackets, negative 2, comma 4 on 3. That's all. This is simply my interval. As simple as that. Now, let's come back to this. So, let's see how we finish all this straight away. Right. Okay. So at this point, I move to D. For the D part, is saying that absolute of 3 minus 2x is greater than 1, right? Absolute of 3 minus 2x is greater than 1. Now we've made a greater than once again. Here, please don't do as I did here. Don't bring it's less than negative. No. We take it individually. I will take the positive form, that is 3 minus 2x is greater than 1 as one equation or one inequality. It's not an equation. Then I'll take negative of the expression 3 minus 2x should be less than what? Oh, sorry, should be greater than 1. I mean, we are producing, we are trying to reproduce what you have here. What I'm trying to do is absolute sign can produce positive or negative. Taking a positive instance, this one will be greater than 1. Now, taking a negative instance, this is negative of this, should be still greater than 1. But here, when I'm solving, I'll have 3 is okay, no, yes, let me bring the 1 to this side and send this one. So I have 3 minus 1 to be greater than 2x, right? So here I'll get 2 greater than 2x, and obviously x will be less than or 1. Is that not it? When I come here, I'll have negative dividing through the equation. I'll have 3 minus 2x. When I divide through by negative, my sign will change as less than. Then I'll have what? Negative 1. Is that not it? Here, what do? I still simplify. So 1 will come here. I'll have 3 plus 1 should be less than 2x. Here, I'm going to have 4 less than 2x. And obviously, x will be greater than what? 2. So we can see that I have x less than 2, x greater than 2. And these are disjoint sets. We can't join them. So our solution for inequality, we simply write the interval form. This is what? X less than 1. So 1 will be the biggest. Open, comma, negative infinity. Because the smallest will be negative infinity. Now we come here, union, x greater than 2. 2 be the what? Smallest as well, right? So 2 comma positive infinity. Now let me change here. It should be negative infinity to 1, because negative infinity will be the smallest one. Yeah. So this is simply our solution for inequality. Now let's solve our very last question here. Then we are good to go. Okay, so that is E. For E part, we have a quadratic equation within our interval, right? That's so nice. Less than what? Negative 3. So for this one, you need to get your calculator, because if you have a quadratic within, we are still going by the norms, right? We are still going by the norm. It's not changing. Okay. But the truth is, you need to simplify this expression. So we cannot just straight bring greater than negative 3. Okay. So this is what I will do. Let's take it step by step. Now let me take the positive part of it. So I have x squared minus 2x plus 3 should be less than what? Negative 3. That was one part. Okay. So solving this, I'll bring my negative 3 to this side, and I'll have x squared minus 2x plus 6 should be less than 0. So this quadratic here. So what do? You punch it into your calculator to get the answer. Calculator. So I have 1 negative 2 6. Yeah. So this is giving me a complex number. A complex number. So you just have to hold on with this. Now let's take the negative part. So negative part is going to be what? Negative of the expression x squared minus 2x plus 3, right? Is greater than, now, oh sorry, so negative of this expression, then that is, I'm taking the negative part of, negative version of this, and that will be less than negative 3 as I have in the question. But because I have negative here, I'll divide through, and I'll be left with x squared minus 2x plus 3 is greater than, here will become positive 3. And at this point, what do? I carry my 3 inside to get a complete quadratic equation, right? So to get our complete quadratic equation, we solve it, then we get our solution. So here we get it as x squared minus 2x plus 3 minus 3 is greater than 0. So I have x squared minus 2x should be greater than 0. We factorize s out, okay? Here becomes so simple. X minus 2 is greater than 0. So here s is greater than 0, x minus 2 will also be greater than 0. So let's see, s is greater than 0. Here we'll be getting, now there's one thing you need to take note of here. Let me clear this here. One thing you need to take note of here is, whenever you are doing a quadratic within an inequality, we shouldn't move straight to judge the inequality signs that is greater than or is less than. Okay, so let's see something here. We do some kind of testing. So here you change this to an equal sign. So you get x is equal to 0, you get s is equal to 2, right? But our sign is greater than. Okay, our sign is greater than. If you are to do a testing simple by one by one, you realize that whenever you take any number less than 0, this will be defined. Okay, so now our solution will simply be x will be less than the smaller number, that is the smaller root, then s will be greater than the bigger root. That's all. Now let's test it and see. Now if I put s anything less than 0, let's say -1. So if s is -1, I'll get what? -1 minus 2. And -1 minus 2 is -3. Multiply by the -1 outside, I'll get +3, and it's greater than 0. When I take any number greater than 2, I get 3. 3 minus 2 is what? 1 times 3, 3. And it's also greater than 0. So this simply becomes the solution. The reason we held on here is we are getting complex roots. But remember, we are in the raw number domain. In the raw number domain, we don't accept complex numbers. Okay, so meaning the only right solution for x or for our quadratic inequality is x less than 0 union s greater than 2. And that brings us to the end of the second problem. Now let's go to the third part. Let's quickly go to the third part. Let's see. Kindly solve alongside and make sure you punch everything you're doing here on your calculator so that you don't get lost. Okay. Okay, so now let's see. He's saying that show that this is a set 1, comma 1 out of 2, comma 1 out of n to infinity. Okay, he says that show that this set is bounded, let's underline bounded, and determine its greatest lower bound and least upper bound. So we have to determine that this is bounded. Now you realize that we are trying to apply the principle of the theorem, which is Bose-Weierstrass theorem. Okay, so that theorem is saying that if you have a bounded infinite set, then you should have at least one midpoint, right? But here we aren't interested in the limit point, but we are to look for the greatest lower bound. Okay, and we have to show that it is bounded. Yes. How do you show that it's bounded? You can only show by giving what boundaries. So you are going to say that this set is bounded by 0. Yep. This is because there is no way this set will ever reach 0. The more n is going higher, if you have 1 out of 2000, it will still not be 0. So 0 becomes a boundary. We can also say that 2 is a boundary because this set cannot be what? Cannot be greater than 2, cannot reach 2 actually, because the highest number is 1. Then it says that determine its lowest bound and least upper bound. So this is just an application of what do we say, bounded set. Okay, so the show part is not anything big, just get some boundary and explain showing that the set here will never exceed that mathematically. That's all. Okay, so now let's see, if we have to find the greatest lower bound, what's the lowest number here? And that is going to be 0. 0. So our GLB is simply what? 0. And what's the least upper bound? The highest number you can ever get is what? 1. That's the least upper bound. That's the highest boundary. You can choose a boundary. Yes, 3, 5, anything greater than 1 is a boundary. But the least of it is 1. So our ULB, which is least upper, oh no, sorry, LUB instead, is going to give us 1. That's all. Our greatest lower bound is 0. Our least upper bound is 1. That is all. Now, it's saying that again, identify some limit points and show. And how does it illustrate the Bose-Einstein? Oh, okay. So we have it here. Now, it's saying that we should try and identify some limit points. And how does it? So, as I said, Bose-Einstein's theorem is saying that if you have an infinite bounded set, then you should have at least one limit point. This is an infinite set. Yes, it doesn't end. Then you realize that it's a bounded set because we've been able to identify the greatest lower bound and the least upper bound. Now, what will be the limit point? You assume that the limit point is less than 0. Once you do this assumption, the next thing to do is to find any delta. Let's say our delta is 0.001. So if you want to find an interval, you have 0 minus this, so negative 0.001, comma, positive 0.001. And surely we are going to have a member of this set within here, because we can have something like 1 over 1000, 1 over 10000. They are all parts of this interval because n is constantly increasing to infinite, if infinitesimal. Okay, so because of that, this becomes a valid interval and 0 is therefore a limit. So you just say that 0 is the limit point and you illustrate it with the interval. Now finally, let's see the last problem. The last problem. So the last problem is saying that consider the sets 1, comma 1.1, comma 0.9, comma, so let me write it here. I have 1, 1.1, 0.9, 1.01, 1.01. No, this is 0.9, 1.01. All right. Then here is 0.99, 0.99, comma 1.001, comma 0.999 to infinity. 1. Is a set bounded? That's the first question. Is this set bounded? You realize that we have 1. This 1, we came to 1.1. We came to 0.9, 1.01. So you can see that the highest number we are seeing is 1.1. And this is now going 1.01. Here is 1.001, meaning the next one to come will be 1.0001. And meaning that we cannot exceed 1.1. That will be the biggest number. Then let's see the smaller part. I have 0.9, 0.99, 0.999. So meaning 0.9 obviously will be the smallest number. Meaning that our set is bounded. Yes. Because no matter how far you go, though it's infinity, but I can still say that my set will never reach 0.9 again and will never reach 1.1. Anything, greater than or less than. So we can say that it's bounded, and you can see some of the boundaries are maybe it can be 2, it can be 5, because the least upper bound is what, 1.1. Then the greatest lower bound will be what, 0.9. Okay, and that is why it's saying, does it have a greatest lower bound and least upper bound? Yes. Least upper bound is what, 1.1. That would be the biggest number in this set, though it's infinity. Then the greatest lower bound is here, 0.9, the smallest number. Now it says determine its limit point and determine if it is closed. So with this, just take any random number within it. Let's say 0.9. Is 0.9 a limit point of this set? Let's take delta neighborhood. So delta to be equal to the 0.01. So if I'm finding the interval, I'll have my center 0.9 minus this. So I'll have 0.899, comma 0.9001. So with these two interval, this interval, am I seeing any other member of this set? Or will I get any other member of the set aside the 0.9 itself? That is 0.000901, right? And I have 0.98999. So let's choose another. Remember that limit point is saying that there should be at least a delta. So that means that some delta will not work, some delta will work, right? Yeah. So for every delta instead. That is isolated points. There are two confusing concepts. So for every delta. So now let's analyze it very well. As this set is going, we're getting 0.9999 as you're moving on. And you realize that you are having for the bigger one to be going 1.0000 in that order 1. So the 0.99 will be increasing. Choosing 0.9 as our center and our radius, let's say 0.01, you simply have let's say 0.9 minus 0.01. Yeah, that's 0.89. Yeah. Then you have 0.9001. So 0.9001. So we ask ourselves that, do you have any other member in here aside 0.9 that will fall with this interval? Right? That will fall within this interval. no matter even as you are going. Because even as you are going, you are getting multiples of 9, and this one too is becoming lesser. So that should tell you that no, yes, we didn't have, right? We didn't have. Because none of them will be 0.9001. None of them at any instance. Then let's see 1.1. For 1.1, if I take 0.001, then it means that I'm going to have my delta to be, let's say, 0.01. If delta is 0.01, now I chose delta 1.1 as my center and delta to be 0.001. So my expression for the interval is simply going to give me 1.1 minus this. So 1.1 minus 0.001. And that will give me 1.099, comma. Then the next one I'll add 1.1 plus 0.001. So that one I'm getting 1.101, right? So within this interval, aside 1.1, would I ever get any member within this interval? Oh yes, I will surely get a member. I will surely get a member. Now this is because within this interval I have 1.099999, which is almost like 1.01, right? But I choose my center to be 1.1, and that means that 1.1 can be a limit point, right? So right now the only problem was with the 0.9, which we had to find if it had any member within, any member aside 0.9. But um, because this is an infinite set, all right, but remember that you can predict the trend, which is 0.99. They're all increasing, yet they are becoming very, very, very small, right? So there's no way we can get a number here, because here is 0.89. The next one maybe 0.9, we have taken that one out, and there's nothing less than that here. Here too is up to 0.9001. We can't get 0.9999. So therefore we can choose 1.1 as a limit point, but he says and determine if it is closed. This is not a closed set, like it's not a closed set on this note, because we just choose 0.9 and we chose a very small delta, couldn't find any of them. Okay, so this is the end of this review exercise. Thank you for watching. Please don't forget to subscribe, like, and share.